Hello students, good morning. Welcome to my lecture on chapter number 10 Halogen Derivatives, class 12 Science, Maharashtra State Board New Syllabus 2020. In the previous lectures, we have studied about SN2 mechanism, that is what substitution nucleophilic bimolecular reaction. But today we are going to study SN1 mechanism, that is what substitution nucleophilic unimolecular reaction mechanism that we have to study. So let us start. This topic is very important and very interesting. Is what SN1 mechanism. You know that S stands for substitution, N stands for nucleophilic, and 1 stands for unimolecular. See, SN1 reaction is what unimolecular. We have one question, why it is unimolecular. So the nucleophilic substitution reaction whose rate determining step contains only one species, then the reaction is called as what? Substitution nucleophilic unimolecular reaction. And you know that rate determining state is written as what? RDS, and C, it is what? Slow step. Remember, rate determining step is always slow step. Now let us start with SN1 mechanism. See, first consider example. Consider alkaline hydrolysis of tertiary butyl bromide. This tertiary butyl bromide is what? Tertiary alkyl halide. Now see the reaction. CH3 Br. So you know that to this carbon atom 1, 2, 3 carbon atoms are attached. So it is what? Tertiary. Now we can take potassium hydroxide or sodium hydroxide, but it must be aqueous. That is what? Aqueous. Heating is required. What happens? Br is substituted by OH. So we get CH3, here you get what? OH plus KBr. Now write down the name. Here it is tertiary butyl bromide. Now it is tertiary butyl alcohol. And see, in the ionic form, this reaction is written as CH3 Br. Here you get what? OH nucleophile. Heat CH3 OH plus Br. See, it is here, it is called as what? Substrate. And here it is called as attacking nucleophile. It is what? Attacking nucleophile. And here it is leaving group or leaving nucleophile. and it is what? Product. See, this is what? Substitution nucleophilic unimolecular reaction, because here OH cannot attack from front side as well as OH cannot attack from back side. Why it will not attack from front side? Because Br is nucleophile and OH is nucleophile, therefore they repel each other. And see, if the backside attack of OH is also not possible because of crowding of methyl group. So crowding of methyl group prevents the attack of OH. Now let us start next point. I hope you understood this first point. Now come to the second point, kinetic expression. See, here rate of the reaction R does not depend on the concentration of nucleophile. It will depend on concentration of tertiary butyl bromide. Tertiary butyl bromide. It can also be written as R equal to Ch3 times Cbr, where K is called as specific rate constant for the reaction. Now see, here the rate of this reaction depends upon concentration of only tertiary butyl bromide. Therefore, it is first order reaction. That is, it follows first order kinetics. Therefore, it follows what? First order kinetics. Now come to the mechanism. First of all, you remember it is two-step mechanism. See here, step 1. That is what? Hydrolysis of Cbr bond. This we have to study. CH string, here you get CH string, then here CH3, here you get Br. Now this step is very important. Step 1, that is hydrolysis of Cbr bond, is what? Is rate determining step, because it involves formation of carbocation. Carbocation is what? Is the species in which carbon having positive, center carbon having positive charge. step 1 involves only one species, that is tertiary butyl bromide. It is what? Tertiary butyl bromide. You know that in this hydrolysis of CBr bond means what? Breaking of CBr bond. In this, OH or nucleophile, strong nucleophile have no role in the step 1. Why? Because the attack of OH is prevented from front side. It is what? Front side, and it is what? Back side. So attack of OH is prevented from front side as well as back side. Already I have explained about that. So what happens here? This step is what? Slow. So rate determining step, and see this step is what? Reversible. What happened here? The breaking of CBr bond take place, and you see here hydrolysis. Hydrolysis means what? Both the electrons goes along with Br. So what happens? Here you get what? CH string, CH string, CH3, having this carbon having positive charge, and here you get what? Br along with both the electrons. Here carbon loses both the electrons to Br. Therefore carbon acquires positive charge and Br acquires negative charge. This is called as what? Tertiary butyl carbonium ion. Carbonium ion. And you know that here this carbon atom is what? sp3 hybridized. But this carbon atom is what? sp2 hybridized. And this is what? Planar. It is planar, and it is what? Tetrahedral. Having what? It is tetrahedral, it is planar. Means carbonium ion having planar geometry, but tertiary butyl bromide having tetrahedral geometry. As well as this carbonium ion is what? Stable. It is what? Stable. Now this is the step 1. I hope you understood this step 1. Now we will proceed for step 2. That is what? Formation of COH bond. This you have to study. It is CH string, CH string here, H3C having positive charge. Now here OH plays important role. This OH is nucleophile. It has 2 electrons, or we can say a pair of electrons. This pair of electrons is responsible for the formation of COH bond. This step is what? Fast. So here this OH, you know that carbonium ion, tertiary butyl carbonium ion is stable and it is having positive charge. So, and OH has negative charge. So OH can attack from front side as well as OH can attack from back side, and therefore you get what? You get CH3 CH3COH. That is what? Tertiary butyl alcohol, having what? Racemization of configuration. I have written here racemization of configuration because what happens here? See, here you get CH3, 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 here you get what? OH. It is what? Retention of configuration. Retention of configuration. It is called retention of configuration because instead of Br you get OH. Now if you put here mirror, then what happens? You get different structures. CH3. See, it is possible when OH attack from front side. Now come to see what happens when OH attack from back side. See, here you get what? Here you get what? Mirror, and therefore that time what happens? OH comes to this side. Here you get CH3, H3C, and here CH3. Here what happens? The configuration of OH become inverse, and therefore it is inversion of configuration. Inversion of configuration. Inversion of configuration. It is 50% and it is 50%. So you get what? These two type of structures for this, and therefore the mixture becomes what? Racemic mixture, and it is optically inactive. I hope you understood this part. In the exam, no need to write down this part. This is about what? Racemization of configuration. That I have shown. See here, it is possible due to front side attack of OH, and it is possible due to back side attack of OH. See, both have equal amount, 50%, 50%. So it is what? It is optically negative because it is a racemic mixture. They are also called as what? Enantiomers. Okay, so it is about step 2, that is formation of COH bond. Now come to the silent features. Silent features of SN1 mechanism. First, it is what? Two-state mechanism. That already explained. Mechanism. One step. Second, one step is what? Hydrolysis of CBr bond. And third is what? Attack of nucleophile. That is what? OH. And fourth one is what? Racemization. Racemization of configuration. These are the silent features of SN1 mechanism. Already we have discussed about all these 1, 2, 3, 4 points. Now we are going to study factors influencing SN1 and SN2 mechanism. Factors in SN1 and SN2 mechanism. First point, nature of substrate. Nature of substrate is very easy. For SN1, order of reactivity of substrate can be written as tertiary alkyl halide greater than secondary alkyl halide greater than primary alkyl halide. But for SN2, see here I have written this order because in this case tertiary carbocation is formed, in this secondary carbocation is formed, in this primary carbocation is formed, and you know that tertiary carbocation is more stable than secondary carbocation, and secondary carbocation is more stable than primary carbocation. You remember in SN1 tertiary carbocation is formed as an intermediate. Now come to SN2. Here primary alkyl halide, secondary alkyl halide and tertiary alkyl halide. In this carbocation is not formed and therefore it is SN2 reaction. See here what happens here, least stable carbocation is formed here. What? Least stable, and here more stable carbocation is formed, but here least stable carbocation is formed, and therefore in SN2 primary alkyl halide is most favorable. Okay. Now second point, nucleophilicity. Nucleophilicity of the reagent. For SN1, see the name SN1. In this, the rate of the reaction or rate determining step contains only substrate, because here rate of reaction depends upon concentration of substrate and not on the nucleophile, and therefore here weak nucleophile is used. Weak nucleophile favor SN1 reaction. And see for SN2 means what? Rate of reaction depends upon substrate as well as on the concentration of nucleophile. So here strong nucleophile favor this SN2 reaction. Now last point, that is solvent polarity. You know that solvent have two types, polar and non-polar. See here, solvent have two types, polar and non-polar. If you consider polar have again two types, protic and aprotic. Protic means what? H2O, ROH, they are what? Protic solvent, because they can easily donate proton. They can what? Easily donate proton. So they are protic solvent, and aprotic solvent like CH3, CO, CH3. See, it is polar. It is carbon having positive charge and oxygen having negative charge. It is polar but aprotic because they are not able to donate proton. So it is aprotic solvent. C, aprotic. And non-polar means what? You can consider benzene or cyclohexane, etc. Cyclohexane, etc. They are what? Non-polar solvent. Now, for SN1, we use polar protic solvent. Polar protic solvent because there is a formation of carbocation, means breaking of CBr bond take place. That is possible due to what? Polar protic solvent. And in SN2, we require polar aprotic solvent because there is no formation of carbocation. In SN1, carbocation is intermediate, but here it contains, here transition state is present which contains pentacoordinate carbon. This is about what factors influencing SN1 and SN2 mechanism. I hope you understood all the points clearly. One question arises. You know that for SN1 there is what? Br ions as well as OH ions. But Br ions are substituted by what? OH ions. That time what happens? Because of polar protic solvent, Br is protected. Br is what? Protected, and therefore Br is not able to attack carbocation in SN1 mechanism because of this polar protic solvent. And so we can easily get attack of OH on carbocation and you get favorable product. I hope you understood all these points. Thank you very much. We will meet in the next lecture. Thank you very much. Stay home, stay safe.